In Lesson 7-4, we are going to look at patterns, relationships, and how to write expressions to determine the next term of a pattern. In this video, I'm going to go over several examples with you so that you know how to do the activities for Lesson 7-4 on your own. This problem says to write the first 5 terms of a numerical pattern that begins with 2 and then adds 3. So it begins with 2, adds 3. So I'll start with 2, and each term thereafter will add 3. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and 11 plus 3 is 14. That's 1, 2, 3, 4, 5 terms. The next part of this problem says to write an expression for the 6th term of the pattern. Well, I know that we started with 2, and then each time we're going to add 3. So since I'm going to need the 6th term, I would add 3 5 more times on top of the first term. That's 1, 2, 3, 4, and 5. Now, that's kind of lengthy to write it that way. So another way that we could write the expression is to write 2 plus, and then since we're adding 3 each time, I would say 3 times 5. It's important that you realize we're writing this expression for the 6th term of the pattern, but we're only multiplying by 1 less than that because we already have 2 as the first term. So you kind of have to subtract 1 from what you're multiplying 3 by. Then it says to write the 6th term that the expression would equal. So I know that the order of operations says here that I have to do what's in parentheses first. So I'll write the answer to that part of the problem, which is 15, directly underneath, recopy everything else where it is, how it is, and then finally 2 plus 15 is 17. Let's just double check. If I were to go up to my pattern here and add 3 more to 14, do I get the same exact answer? And I do, so I know that I'm okay there, and the expressions I wrote are okay. This next problem says to write the first 5 terms of a pattern that begins with 5 and then adds 5. So 5, I know that I'm just skip counting by 5 here, 5, 10, 15, 20, and 25. Then it says write the first 5 terms of a pattern that begins with 20 and then adds 20. 20, 40, notice I'm using commas to separate the terms, 60, 80, and 100. Then it says circle the corresponding terms. So we need to understand what the word corresponding means. Corresponding means that they go together. Each of the first terms in these 2 different patterns would be corresponding. So the first terms here would be 5 and 20. Those are corresponding. 10 and 40 are corresponding. 15 and 60, 20 and 80, and 25 and 100 are corresponding. The next question says, how does the top term compare to the bottom term? When you write the answer to this, you have to be sure to say what the top term is in relation to the bottom term. So when I look at the top term, let's do this one as an example. Here we have 25, and the bottom is 100. I know that we would divide 100 by 4 in order to get 25, but that is still talking in terms of the bottom compared to the top. I need to know how the top compares to the bottom. So I will use the reciprocal of 4, which is 1/4, and say that the top term is 1/4 the bottom. The last question says, how does the bottom term compare to the top term? And since you're asked how the bottom compares, we need to start our sentence with the bottom term. And then we say what the bottom term is in relation to the top. We already talked about the relationship. The bottom is 4 times as great as the top term. So again, I just want to repeat, if you're asked how does the top term compare to the bottom term, your sentence should start with the top term is, and then say how that mathematically compares to the other term. And our last slide here has a table. And this is a real-world situation, cost of music downloads. On the top we have number of songs, and on the bottom, cost and downloads. So for one song, it would cost 99 cents to download. For 2 songs, it would cost $1.98. To determine the rest of this mathematical relationship, I would have to look at, well, what do we do to go from 99 cents to $1.98? And I know that we are adding 99 cents each time. So here, the very first thing we're supposed to do is complete the table. Adding 99 cents would be just like adding $1 and then subtracting 1. So $1.98 plus 1 is $2.98. Take 1 cent away, that's $2.97. The fourth would be $3.96. And finally, the fifth is $4.95. The next thing says, describe a relationship shared by the corresponding terms. Remember, corresponding means the terms, the value that is in the same term, both top and bottom. So I know that for each of these numbers of songs, it costs 99 cents. So the amount of songs times 99 cents would give us the cost in dollars. So we could say that the number of songs times 99 cents equals the cost. We could also say the cost in dollars is 99 cents times the number of songs. So then the final question says, what would be the cost of downloading 6 songs? Using the relationship that we just came up with, I could simply say, well, 6 times 99 cents would give us $5.94. I can also figure that out by adding 99 cents to the last term, since I knew that the pattern shows 99 cents each time.